Welcome to Study Loop.
Here we have a compound interest problem, and we're going to use our non-continuously compounded interest formula for the majority of Part A. The amount invested is $1,000 for a time period of 3 years with an interest rate of 8%, and that translates into a decimal value of 0.08. And so we're going to go through several different amounts of compoundings per year, starting with annually, once per year. We use n equals 1, and we get $1,259.71. Then for quarterly, we use n equals 4. We substitute that into our formula, and we get $1,268.24. For monthly, n equals 12, and that gives us $1,270.24. For weekly, n equals 52. That gives us $1,271.01. We see the amount of money is growing, but the rate of growth is slowing as we accumulate more compoundings. For 365 compoundings per year, that would be daily, we get $1,271.22. And hourly, that would be 8,760 compoundings per year, we get $1,271.25. And for the last part, we're going to do continuous compounding, so we use a different formula. The continuous compounding formula is A equals A naught e to the RT. So we still have the same interest rate, 0.08. And we still have the same amount of time, 3 years, and we still have the same initial investment. And we end up with $1,271.25. Finally, for Part B, we want to graph the continuously compounded function for different amounts of interest rates. So 6%, let's try that again. We have 6%, we have 8%, and we have 10%. So let's grab a graphing calculator. We type those in. And then we're going to look at them from time 0 to time 3. So we can go to window and we can change our window dimensions to go from 0 to 3 on the x-axis. And then I chose negative 100 to 1600 for my y-axis. And then looking at the graphs, the lowest one, logically, is the one that has a 6% interest rate. And the middle one is the one with an 8% interest rate. And the highest one is the one with a 10% interest rate.